In this video, in the acceptance sampling lecture series, I'm going to show you how to create a double sampling plan operating characteristics curve. In the previous video, we have shown you how to create these single sampling plan operating characteristics curves, and then this one we're going to show you how to create this curve for a double sampling plan. The situation arises when you find that if it's your acceptance criteria is 2, however you have found that you found 3 defectives or 4 defectives, not too much defective but very close. So in that case you may think maybe I will take another sample in case I may accept the sample. And so in that kind of situation, what the operating characteristics curves look like, because that defines whether you're gonna make any money at all by doing double sampling plans or not. So first let's create that double sampling plan, and then we'll explain the benefits and whether we should have. So what I'm gonna do is I'm gonna copy that all single sampling stuff to this double sampling plan, because a lot of this it's gonna be kind of same. So the historic probability in the lot, so this column basically represents the defective number of defectives in the lot. So this 5,000 lot that we are producing, historically it has. So these are the numbers fakely created by me. So what if the probability is 0? There is not much defect in there. What if the probability is 1%, probability is 2%, 3%, 4%, and so on. So for each of these probabilities, we're going to create that acceptance. So these are the defective probability, or in percentage, this is the defective probability, defective in percentage, and then we calculate the defective in and then we calculate the acceptance probability of acceptance. This was the acceptance probability. Let me do a format, so because I will need a whole lot of columns this time, so I'm gonna do wrap text, and this is also the acceptance probability. However, it's in percentage. So instead of probabilities, let's write accept as percentage. Excel will not correct your grammar or typos, so you gotta be careful on working with Excel. Word does it automatically, Excel does not, because in Excel you can basically, it's a math type, so it could think that you're writing some math or some kind of acronyms, which Excel does not have. So that's why it doesn't try to correct by default. So we're creating double sampling plan. So now let's imagine that this is our first sample, and then create one more, insert one. Then in the second sample, typically people take a little bit more, almost twice. We'll see how to calculate this sample size later in the course. First, now just say assume that it's about 300. So this would be the mean defective in the first sample. So I'm gonna write mean defective in the first sample like that, and then we're gonna need another one, mean defective in the second sample. So this is 300 sample size. Instead of 300, just write, I actually wanted to write and 2, not really 300. So let's do that. Or we could basically write it here. So that would be N1 is 120 and 2 is 300. So then if we use this, sell this, and then freeze that, and then this one use this and then freeze that. So now if I do that way, then if I change one of these, then they will change. So that's kind of cool about this. And then make C1 is say 2, keep our earlier stuff, and then C2 keep it say 6 for example. Now the acceptance to C2, you must be careful about this little bit, because this C2, I'm going to put that in the star. This C2 actually also contains C1. So C2 also contains C1. So what you're trying to say here is in total from the first sample and the second sample, if we can only accept maximum 6 defectives. So if you already get 3 defectives in the first sample, you can only get another 3 in the second sample. So this C indicates basically how many total, including combining the second sample and the first sample. That's C2. So you must be careful on that. Now we need to set another criteria called rejection criteria. What this indicates is basically when do you take second sample. So this R basically tells you when to take the second sample, or when not to take the second sample. Basically when tells you when not to take the second sample. Sorry about that. What that indicates is basically if you get in the first sample, if you get 0 defective, you accept it. 1 defective, you still accept it. If you get 2 defective, you still accept it. However, if you get 3 defective, then you take the second sample. If you get 4 defective, then you take the second sample. If you get 5 defective, you don't take any more sample. So you stop at your first sampling plan, because you said that that's too much. We will not even considering this lot is too bad. We'll not even consider taking the second sample. Same thing you have for something like R2, which is basically R2 is type kind of redundant, is basically C2 plus 1. So you may not need R2 basically. However, what that indicates, in case if you go for third sampling, fourth sampling, fifth sampling, things like that, then this R2 is significant. Otherwise, R2 is not really significant in a double sampling plan, because what R2 indicates is if you get 7 defectives combining the first sample and the second sample, then you don't take any more samples. So basically that defines that this is a double sampling plan, because if C is your acceptance criteria, C2 means that combining the first defect and the second sample defect, the maximum you allow is 6. But in the what if you get 7? Then you stop doing it. Now if you set this R2 for example 8 or 9, things like that, that indicates that you still take a third sample. So for a double sampling plan, R2 is not really that important. Let's go ahead and create all this stuff. We need to create the double sampling plan. So I have this this is the average number of defective in this sample. Now let's calculate the average number of defective in the sample 2. So this is the historic probability or population probability in this lot times the sample size. So that is the mean value of defective if you take a second sample. Now let's create a few more columns. So this is the percent of acceptance for single sample. So I would like to rename that single sampling acceptance probability, PA. I would like to call that PA1, defined like that. And this would be then single sampling acceptance percentage PA, that would be 1. So this is in percentage. That should be actually times 100 to indicate that this is in percentage, like that. So now we're going to create some situation based on this criteria that we have set. So in this case, if you look at it, this probability is based on that acceptance, original acceptance number. Let me change that to this, and basically I'm going to delete that like that. Okay, so now, yeah, so that is C1 based on the acceptance number at first sample. So you allow maximum 2 defective all the way up to 2. Now there may be some situations I'm going to add one, insert one row here and title that as case 1, just for our convenience. For case 1, imagine that in the first sample you get defective number of defective 3. So if you get 3 in the first sample, then in the second sample, if you get 3 in the first sample, then in the second sample you get only 3 in the first sample, then your R1 criteria is 5. So then you take the second sample. So you already got 3 in the first sample. Now maximum you can get in the second sample is another 3, because your total criteria is 6 now. So this is your situation 1. Now case 2, we can say, let me close this a little bit like that. It's gonna look nicer like this. Now case 2, we can have something like this. Say your first sample, you get 4 defective, D1 equals 4 defective. Then in the second sample, how many you can have more? Because you already got 4. Now your criteria is 6. So maximum you can get defective in the second sample was, I think I should put this symbol 2 in this here too. So less than equals 3, like that. So here, if you get 4 defective in case 2, if you get 4 defective in the first sample, because your criteria is 6, then you can maximum get 2 defective in the second sample. So you will accept the lot, the entire lot, if you get 4 defective in the first sample and either 0 defective, 1 defective, or maximum 2 defective. Now what if you get, let's say, is there any case 3? Case 3 would be if you get 5 defective in the first sample. Then it says if you get 5, stop. You don't have to take any more sampling, because this lot is so defective, we are done with it. So just reject. So we are done. We don't have any case 3, but depending on what is the R value, you can have case 3, case 4, case 5, and case 6, things like that and so on, in theory. But you will see that we really don't need that much. So let's go ahead and calculate all this probability. So I'm going to calculate the probability of getting 3 defective in the first sample. So equals Poisson dot dist, and then 3 defective in the first sample. The mean value for first sample is this, comma, it's not cumulative. Be careful. We're trying to calculate exactly 3 defectives. So it's just the probability associated with this. We are trying to calculate P probability of X equals 3, exactly 3. Then you use non-cumulative. Copy all the way down. Now in the second sample, we are actually calculating cumulative. Poisson.dist. So 3 defective in the second sample. Mean value for second sample is this, comma, we are doing cumulative less than or equal to all the way up to that point. So that is the probability second sample. Case 2, in the first sample, Poisson.dist, that is 4, comma, mean value is first sample mean value this, comma, we are calculating D equals 4. That means just the probability associated with 4 defective. So that is not cumulative. That's non-cumulative. Copy all the way down. Similarly, calculate the second sample probability. Poisson.dist. X value 2. Mean value for second sample is this, comma, cumulative probability now because it's less than or equal to. By the way, you can calculate all of these probability using binomial distribution. You're going to get exact same thing. You guys have seen that before. So we have case 1, case 2, case 3. Now we're going to calculate the probability for case 1. So let's say case 1 probability of acceptance PAC1. I'll just write this way, PA probability of case 1, something like that. So probability of case 1, basically if we get 3 defective in the first sample and this defective in the second sample, then so we are using a language and in the probability world, if this and this have to happen, then you multiply them like that. If 2 conditions have to satisfy, then you multiply the 2 conditions probability to get the final probability. Now similarly do the same thing for case 2 probability. I'm gonna just type here instead of 1 I'll do 2, so that will give us the case 2 like that. All right, so here is equal to same thing, this and this. If I get 4 defective in the first sample and any of this true, then that's the probability. So the total acceptance in at the second sampling plan, the total probability, let's say probability of acceptance by, I would say, at second sample. Be careful about this language. I use at second sample. So this is not probability of first sample and second sample. It's only, so the first try we didn't accept it, so this is the probability only accepted at the second try in the second sample. So that you have it, we will accept this either in case 1 or in case 2. So now see the language here we using is or. Or means in probability world, basically you add the probability to get the total. So this or this, that will give you the total probability of acceptance at second sample. Now the combined probability because the total probability of acceptance, basically, it could happen that you only got just one defective and you accepted at the first single sampling plan. You didn't even do all of these. So if you do double sampling, the total probability will be this plus this. So it could happen that you could select a sample just by first try or by the second try. So this is, again, we are using OR language, so you're gonna basically add these two. So the combined probability of acceptance by double sampling plan, PA. I would like to call that like PA underscore 2, like we indicated here, PA underscore 1, like that. All right, so this is basically equal to this or this. Copy all the way down like that. Now we calculated all of this probability. Let's express this in percentage. So the percent of combined probability of acceptance by double sampling plan, I'm going to kind of shortcut it, 100 times PA, probability of acceptance, and then in the second try. So this is basically equal to 100 times this probability. Probability is out of 1. We are expressing this is in out of 100, which makes a little bit easier to understand. Now let's plot the defective and the single sampling plan operating characteristics curve and double sampling, and go insert, go here. No, I think I want XY plotter. So it looks like I selected this one. I should actually select this instead of that, because everything else was selected in percentage. This one I selected out of 1. So that is the double sampling plan operating characteristics curve. So if you look at this orange curve, which is basically associated with the probability associated with the double sampling plan, and the blue curve is associated with the single sampling plan. Let's name this title. So this title would be double sampling plan operating characteristics curve. Now as you can see, the both curves are presented here, the single sampling characteristics and double sampling, just to see the comparison of these things. So this is the percentage of acceptance. This is the defective, percentage of defective in the lot. So this is about the operating double sampling plan operating characteristics curves. As you can see, the acceptance increases a little bit, but it's not really a whole lot. You know, if you look at say this 80% line, so if I draw a line here, for example, C value 2, so you can see the percent accepting somewhere around 58%, and then this is about 61%. On this line you can see about 95. We can actually see this probability right here. So you can see that's 94%, 95% about. In the first sampling plan, about 88%. So it's not a whole lot of improvement. Like this one is 57%, this one is 61%. So you get about 2-3% more chance of acceptance by doing the double sampling plan. The question is, do you have enough resource to do another inspection of 300 sample in the second double sampling plan? So that depends on how much resource you have compared to if you throw away a few lots, how much that cost you. So that's it about the double sampling plan operating characteristics curve. Once again, this thing is called operating characteristics curve because if you change these values, then basically everything else is gonna change and look different. So that's why the probability of acceptance changes, things like that. If you change the sample size to 100 to say 200, you can play with it and then you will see that things are changing. So this will give you an idea how much to sample, what's the proper C criteria, what's the C1, C2. So this will give you the idea of how to set C1, C2 sample size, things like that. We'll talk more about this later.